6. Vertical circular motion and satellite motion. Now we come to vertical circular motion instead of horizontal circular motion. There are two real-life examples. One is roller coasters doing this vertical circular motion. One is this warplane doing loop-to-loop. Now let's analyze the vertical circular motion this way. And we're just going to look at the top position and the bottom position. When the object is at this top position, there are two forces acting on it: its own weight, mg, and the pull of the string, tension. Both of these are towards the center of the circle, so both of these added together give the centripetal force, T plus mg, which is that one there. Then at the bottom of the circle here, this force, the tension force, is towards the center of the circle, but the weight of the object is acting away from it, mg. So this force minus that force gives a net centripetal force, T minus mg, which is that one there, T minus mg. Here is a worked example where a girl swings a bucket of water in a vertical circle, and she swings it at the lowest speed. In other words, at the top of the swing, she's not pulling on the bucket at all, not applying any force, and just let the weight of the bucket provide the centripetal force. And you have to work out the centripetal force and the speed of the swing. The centripetal force at the lowest speed is simply the weight of the bucket with the water, so it's easy. And then, using the figure of centripetal force, we can apply this formula and make V the subject to work out the corresponding lowest speed. Satellite motion, which is also circular motion, as you can see here. The moon is orbiting around the Earth. Newton's law of universal gravitation states that any two objects can be a chair and a table. Yourself and a chair. Doesn't have to be two planets or satellites. They are attracted to each other by a gravitational force given by this formula. F is gravitational force equal to G is a constant, that number is fixed, times the two masses multiplied together, divided by R is the distance between the two objects from center to center, squared. For this example here, we have a 110 kg satellite, that one there, orbiting the Earth, and they exert an equal and opposite force on each other. And the height of the satellite above the Earth is that much, and the mass of the Earth is that much, and the radius of the Earth is that much. And he had to calculate the force of gravity between the two. What you had to watch out for is, for the total distance, you had to add the height to the radius of the Earth to give you the total distance. And make sure that distance is squared. So if you just apply this formula, which is not too hard, and as long as you do the right thing, you should come up with the right answer of 25 newtons.